It can be proved that there is only one positive integer n for which both n and n squared plus 2 are prime. What is this unique value of n? Well, let's see. Let's try n equals 1, n equal to 1, and what happens? So we have n squared plus 2. So that would be 1. That would be 1 plus 2, which is 3. Okay. Well, 1 is not a prime, so this fails. No problem. Let's keep going. N equals 2. This would be 2, and this would be 4 plus 2, which is 6. Okay, well, 6 is not a prime, so that fails. Let's try n equals 3. This would be 3, and this would be 11, and there we go. Both of these are prime. So only one, huh? So I guess this is the one. N equals 3. The squares of the lengths of the sides of a certain right triangle are consecutive integers. What is their sum? So we have some right triangle, and A, B, and C, and as you are well aware, the Pythagorean relationship is a squared plus b squared c squared. So they're saying the squares of the lengths of the sides of a certain right triangle are consecutive integers. Okay, so that basically means, let's see here, we have a squared, b squared, and c squared. These are consecutive integers. So if this is the first number, this would be a squared plus 1, and this would be a squared plus 2. Right? They're consecutive integers. So then just plug that back into here, and you get a squared plus 1 is equal to a squared plus 2. And then if you solve for this, it would be a squared is equal to 1. And therefore, a is equal to 1. Because it can't be negative 1 because it's representing a length. So that means that a squared is 1, a squared plus 1 would be 2, and a squared plus 2 would be 3. Yeah. And what do they want? They want the sum. Okay, so add them up, and you get 6. If a, b, and c are real numbers, what is the only value of a for which the graphs of y is equal to ax plus b and x is equal to ay plus c are perpendicular to each other? So y is equal to ax plus b, and x is equal to ay plus c. Now, the standard form is y is equal to mx plus b, right? Where m is the slope. M is the slope. Okay. So first let's get them in this form. This one is already in this form, so that's fine. So let's make this one in this form. It would be x minus c is ay, and therefore y would be 1 over ax minus c over a. Okay. Now if these two lines are perpendicular, so something like this, that means what does it mean? It means their slopes are negative reciprocals. So the slopes would be negative reciprocal. So let me explain what that means. So if I say, what's the negative reciprocal of 2? First you take the reciprocal, which is 1 over 2, and then you put a negative. So these are negative reciprocals. If I said, what is the negative reciprocal of m? First you take the reciprocal, and then you put a negative. So those are negative reciprocals. So this slope here for this line, this slope is a, and this slope here is 1 over a. So basically what we want is for these two, a and 1 over a, to be negative reciprocals, correct? And therefore, well, let's see here. If this guy, let's concentrate on this guy. If I flipped it, it would be a, and then I have to take the negative. Yeah, and that means these two have to be identical, right? It's just like with this. If I took this and flipped it, it would be just minus m, and then I take the negative to make it positive m, and those two are equal. Same thing with this guy. If I took this and flipped it, it would be minus 2, and then I would take the negative to make it 2, and then those two are identical. So same thing. This a and this minus a have to be identical, and the only way that's possible if 2a is equal to 0, and then a is 0. So the only way that this works is if a is 0, the only value of a for which these two graphs are perpendicular. The vertices of the shaded triangle are midpoints of 3 of the 6 segments into which the medians of a large triangle are divided by their common point of intersection as shown. If the area of the shaded triangle is 1, what is the area of the large triangle? Okay. Well, they drew the graph, so I'm not going to redraw the graph, and hopefully you understand the interpretation of what they've described here. So there is a formula that states that if you have two triangles, the ratio, let's say a small triangle and the area of a big triangle, so area of small, area of big, the ratio is similar to the side length. So let's just call it S. S small and S side length. Side length squared. So that's basically the formula. We're going to use this formula. So they've told me that the area of the shaded triangle is 1. So that means this is 1, this guy right here. So 1 over a, the area of the big triangle. Now the side lengths is what we need to discuss. So if you look at this graph, if, for example, if from this point to this point is this is the midpoint, right here. So if, let's just say the whole length was 4x, this would be 2x, and this would be 2x, the length. You got it? And therefore, since, again, these are the midpoints, this is the midpoint right here. And this is the midpoint, and this is the midpoint, right, of those lines that they're on. So that means that this side right here, from there to there, is x. It's half of this. So the area of the small over the area of the big, which is this, can be calculated by a ratio of the sides, but you have to square them. So the small side is x, and the big side is the whole from there to there, which is 4x. So that is going to allow us to figure out this AB, which is what they want, the area of the large triangle. All right, so 1 over AB, well, the x's cancel, you just get 1 over 4 squared. So then that means 1 over AB is 1 over 16, and therefore AB, the area of the big triangle, is 16. What are both values of x that satisfy that? Okay, well, I think we're going to have to use some sort of a log rule. I'm just trying to think which one. There's this one, the log of a to the base b is equal to 1 over the log of b to the base a. I think that's a pretty good one to use. There might be others that you want to use. That's perfectly fine. I'll use this one. And what I'm going to do is, in order to avoid making this super messy, I'm just going to take it one step at a time. So let's just work on this one first. So the log of x to the base 2, I'm going to call that a to make it simple. And therefore, the log of 2 to the base x would be 1 over a, right? According to this log rule right here. Okay, that's pretty good actually. And what I mean by that is that's going to hopefully help us. As long as I can get everything in terms of a, then I can cancel it all out at the end. I think I should be able to. Okay, now where do I go next? Let's work with this one. So the log of 2x to the base 4 would be, well, first we have to break this up. The log of 2 to the base 4 plus the log of x to the base 4. That's just simple log rules, actually. There's nothing fancy there. And then this, well, this is just a half. This is a number. There's no x in there, so that's just a half. You can do that in your calculator to verify. And then this one would be 1 oh, hold on for a second. What am I doing here? Yeah. I'm using the log rule, log of 4 to the base x. And then this one would be the log of 2 to the power of 2 to the base x. And then using log rules, you get 2 log of 2 to the base x. And then remember that the log of x to the base 2 is just a. So this is going to be 1 over 2 plus 1 over 2a. Hold on. No. 1 over a, sorry. I got to use this one here. Just make sure that I don't mess that up. So it'd be 2 over a. Yeah. And then that would basically be 1/2 plus a over 2. Okay. All right. So we got that one. And then in a very similar way, we will use this one here. So by now, hopefully you're getting the hang of this. So this is going to be the log of 4 plus the log of x. And then in a very similar way, the first one is just 2/3. And then that is 1 over log of 8 to the base x, 2/3. That would be 2 to the power of 3, so that would be 3 log of x2. And then that log 2x, let me just see if I did that right. Sorry, I think that would have been 2 to the base x like that. I just got to make sure I do that properly. So 2/3 plus 1 over 3 over a. So this is 2/3 plus a over 3. And finally this one, and that one by now you're definitely an expert, so I'll let you do it. Hopefully you got to do some work, right? And when you do, you will get 3 over 4 plus a over 4. All right. Okay, so we got, what do we have? We got this one, this one, this, and this. Now we plug it all into that up here. Okay, so let's plug that in. All right, so here we go. So the first one is 1 over a. And then this one was 1/2 plus a over 2. And then this one was 2 over 3 over a over 3. And then the last one was over here, 3 over 4, a over 4. Okay. And then I've got to solve for a. Or, well, yeah, I mean, and then I've got to solve for x. I made that substitution, so. Okay, shouldn't be too bad. All right. Okay, so let's cross multiply. We'll have 1 over a, and then 3 plus a over 4. And then on the other side, it would be 1 plus a over 2, and then 2 plus a over 3. And I think that's pretty good, actually. Yeah. Oh, hold on. This top here, log of x to the base 2 is actually a. Sorry about that. Yeah, I gotta make sure I don't make any mistakes there. That would mess up the whole thing. After all this work, you don't want to make one silly algebraic error and mess it all up. Yeah, log of x to the base 2, right? Log of x to the base 2. So I got to use this one here. Yeah, sometimes I get confused, right? Okay, no problem. So good thing I detected that quickly. Okay, so there's all these numbers in the denominator. Let's get rid of them all. Let's multiply. Well, actually, let me just cross that out, make that a 2, and then multiply through by 6. Yeah, multiply through by 6. 6 times, so that would make this 3a, and then 3 plus a. And then that would make this 1 plus a, 2 plus a, and then a 2. Yeah. All right, so now let's expand, and we get 9a plus 3a squared. And you'd get 4 plus 6a plus 2a squared. And then put everything on one side, a squared plus 3a minus 4. And I think this factors very nicely. A 4, 1 plus minus. Yeah, and therefore a is equal to 1 or negative 4. And then finally go back to my original substitution, which was the log of x to the base 2 is equal to 1, or the log of x to the base 2 is equal to negative 4. So that means either 2 to the power of 1 is x, or 2 to the power of negative 4 is x. So that means that x is either 2 or x is equal to 1 over 16. And therefore, those are the two values that they're looking for. What are all ordered pairs of integers, a, b, with 0 less than a less than b, for which the a root of 2007 times the b root of 2007 is equal to the 9th root of 2007. So let me explain that a little bit. Some of you are familiar with this. Like if I have 2007 just like that, we know that's just 2007 to the half. If I had 2007 with a 3 here, then that would be 2007 to the 1/3, and so on. So this really is 2007 to the 1 over a times 2007 to the 1 over b is equal to 2007 to the 1 over 9. Got it? So using exponent laws, it would be 2007 to the 1 over a plus 1 over b is equal to 2007 to the 1 over 9. And then therefore, since the bases are the same, the exponents are the same, and therefore 1 over a plus 1 over b is equal to 1 over 9. All right, and then you fiddle around with this. Now, this is very important because that means that a is not equal to b, and then we also know that what they've stated, that there's a hierarchy here. What else do we know? They're both positive. Well, that's obvious since they're both greater than 0. I'm just trying to think of some properties that would help us. And then another thing I noticed is that because of this equation, a has to be greater than 9. Because if a was less than 9, 1 over a, like for example, if a was 5, that's already greater than 1 over 9. And if you add an additional number, it's going to be even greater than 1 over 5. So the only way that's going to work is if a is greater than 9. Hopefully that makes sense. Okay. Oh boy. All right, so I've got to come up with some sort of a system here to figure that, because trial and error is going to take way too long. I initially thought trial and error, but I think that's going to take way too long here. Okay, let me just work with this first, and let's see what happens. So I got a plus b, just adding the fraction over ab is 1 over 9. Cross multiply 9a plus 9, well, let me just put it in brackets first, is equal to ab. Okay. The fact that a is greater than 9 is really helpful because we can make it, and then b is greater than a. So that's actually, I think that's going to help. So what we can do is we can call a something. We know it's greater than 9, so it's 9 plus something. We also know b is greater than 9, so it's also 9 plus something. What the something is, I don't know. That's why I called x and y. And let's substitute these guys into here, and I think that might help me, hopefully. So then that means that's 9 plus x plus 9 plus y, and then 9 plus x times 9 plus y. And then let's see what happens here. So we have 18 plus x plus y, and then 81 plus 9x plus 9y plus xy. And okay, let's keep going here. 9 times 18 plus 9x plus 9y. Okay, things are starting to cancel here, which is very good, I think. Yeah, these all cancel, so we're just left with xy is equal to 81. Yeah. Okay, that's very helpful, because now that narrows it down significantly. If x times y is 81, then we have some very limited options. X and y can be, well, x is less than y, correct? Yeah. So that means 1 and 81, or 3 and 27. Anything else? 9 and 9, but x cannot be equal to y, because b has got to be greater than a. And then therefore they wanted ordered pairs a, b. Okay, so I got to figure out a and b. That's not a problem. This is the formula. So that means a and b would be 10 and 90, or you're adding 9, so 12 and 36. And then there you go. Those are the ordered pairs.